I'm presenting on waste to roads and buildings from CSIR BRI, Kumasi, Ghana. I'm presenting with Kwabena A. Boakye and Delali Adjei. The outline of the presentation is as follows. We are going to look at waste plastic scenario, look at intervention by government and other institutions, intervention by CSIR Building and Road Research Institute. Then we would present on some research findings, and then we'll look at the way forward. Now, in many developing countries, including Ghana, disposal of plastic waste through conventional methods of landfilling, incineration, and communal dams are not able to effectively deal with the increasing volumes of waste generated daily. The widespread occurrence of haphazard littering results in heavily polluted beaches, rivers, gutters, and roadsides, and this has detrimental impacts on human health, ecosystems, critical urban infrastructure, and on productivity and economy. Many people are also not aware that plastic is not biodegradable and that it takes a very long time to degrade. And so the populace has not appreciated the dangers that plastic waste have on the environment, animals, and humans. Due to these problems, plastic waste management has become a major concern in Ghana. So now in this slide, you can see solid waste, including plastic waste, dumped outside a waste container. In this other slide, we can see a dump site with stagnated water days and weeks after it's rained. And then here, this is a seashore full of waste, most of which, or majority of which, is plastic waste or plastic bottles. The Environmental Protection Agency, EPA, has revealed that 17.7% of plastic waste materials generated only in the country finds its way into the oceans and wreak destruction of marine natural life. Fishermen complain all the time about harvesting more plastic waste than fish, and sometimes dead fish are found floating on rivers and seas, and this to have died as a result of consuming waste plastic. In some fishing communities, the entire shoreline are covered with filth, which include waste plastic. Fishes that are brought out from some of the seas are kept at these beaches, there's a low craving for purchasing the fish due to the unhygienic surrounding where the fishes are kept. Now, this is killing the business and livelihood of the fishermen affected. About 85% of the solids dredged from choking gutters in some environs are made up of sachet water, plastic, and food wrappers, contributing to causes of perennial flooding in cities in Ghana. This poor and clogged drainage places for mosquitoes and flies and leads to outbreak of cholera, malaria, and many other diseases. There's also smell, which is very common around some of these drains. There are documented cases of cholera outbreaks in some major cities of Ghana, with some deaths recorded, which were reported to have been caused by poor management. In 2015, more than 10 people lost their lives when the capital city Accra was flooded as a result of heavy downpour. The flooding was believed to be caused by choked gutters, clogged drains, due to accumulated waste plastic dumped or blown into them. Some other cities, for example, Kumasi in 2018, had reported cases of flooding in some areas during heavy rainfall. And as a result of clogging of drains with plastic waste, the flood waters could not flow freely through. This resulted in disasters where lives were lost. Despite cloggings and polluting beaches, only 2% of plastic waste ever gets recycled. At the turn of the century, it was reported that there were about 40 plastic manufacturing companies producing about 26,000 metric tons of assorted plastic products in Ghana. There are also over 10,000 metric tons of finished plastic products imported annually. Now, the Waste Management Department of the Kumasi Metropolitan Assembly, KMA, and other waste management bodies indicate that about 16.5% of waste which is generated daily are plastic, with PET bottles forming about a third of it. Also, the Accra Metropolitan Assembly indicated that out of the over 2,500 tons of waste generated daily, only 500, representing 60%, is collected and sent to landfill sites. The remaining 40%, of which the majority is plastic, are left uncollected. This normally causes various health problems in the municipality and the country as a whole. Zoom Lion is a waste management company in Ghana, and this company collaborated with Accra Compost and Recycling Plants and agreed to export PET bottles for recycling in 2013. The collected waste are initially carted to refuse dumps, and this forms huge heaps in the long term without proper recycling, and this poses an immense challenge to the environmental quality as they end up impeding storm drain channels. Now, what are some of the efforts made by governments and other institutions? Here, just a few are listed. There was a decision to ban light plastic materials with less than 20 microns from November 2015 in Ghana by the Ministry of Environment, Science, Technology and Innovation as part of steps being taken to enforce laws governing the production and uses in Ghana. Again, a recent meeting of stakeholders in the manufacturing industry have called for a ban on light plastic materials that are between 20 and 30 microns, as these have been imported to cause more harm. But the ban has not been implemented. UNDP has also organized various activities aimed at establishment of a multi-stakeholder waste resource platform to promote recovery, including plastic waste in Ghana. Plastic Punch and NGOs also started raising awareness about dangers of plastic on the environment, wildlife, and humans, and provides innovative and income-generating waste management solutions to be replicated in other countries. A coalition of private enterprises, that is the Ghana Recycling Initiative of Private Enterprises, from Ghana Association of Industries, AGI, in collaboration with EAP Consults Limited and CSIR BRI, is piloting innovative technologies that recycle post-consumer plastics into valuable products which are already in high demand in Ghana and other countries in the sub-region. The technologies, which are simple, readily available in Ghana, and require low capital startup, low skilled labor, most of the equipment can be manufactured locally, with the resulting products having a ready market domestically and regionally. In Intervention by Council for Scientific and Industrial Research, Building and Road Research Institute. As an institute, our mandate is to take research into all aspects of building and road planning design, construction and maintenance with a view to assist the construction industry to be more efficient, safe, and economical. We have been also mandated to develop local construction materials for increased utilization in construction. So for this reason, the Institute has been conducting research activities into the use of waste materials, and for the purposes of this presentation, we are going to consider waste plastic in construction of roads and buildings. Now, some research and development activities with waste plastics in the Institute include various studies include waste plastic as modification of bitumen for road construction, waste plastic as modification of aggregates for road construction, waste plastic bottles as materials for hauling, waste plastic for partial replacement of fine aggregates for mortar formulations, waste plastic materials as partial replacement of coarse aggregates for concrete, waste plastic material as partial replacement of fine aggregate for cement block, and last but not least is shredded waste plastic tire rubber for mechanical stabilization of marginal arthritic soils for low volume roads. We are going to now discuss our research findings. Findings discussed here include modification of mortar with waste plastic, that is waste PET and HDPE, concrete with waste plastic, again with PET and HDPE, and then modification of mortar blocks using waste plastic, again PET and HDPE. So at this point, Delali will take over. Thank you.
Modification of mortar using waste plastic. The samples were produced in accordance with the ASTM standard, and the average size of the materials were found to be below 1 millimeter, and this falls within the acceptable range as per the ASTM C136 standard. With the water absorption for most of the replacements using waste HDPE were found to be lower than that of the control. Mortar modified with waste PET was also found to generally absorb more than mortar modified with waste HDPE. However, the absorption of both plastic types and for all the replacements were far less than that of the control. Compressive strength. With the compressive strength as shown in the graph. The compressive strength at 28 days for PET out of HDPE at all the percentage replacements. And the percentage replacements were from 1% to 5%. And the optimum strength was achieved at 1% replacement for PET, that is the polyethylene terephthalate, and 3% for HDPE, that is the high density poly within the minimum standard. However, for the mean compressive strength of PET at 3% replacement, the strength was found to be higher than that of the HDPE at 3% replacement. Based on the results we obtained, we realized that the percentage replacement should not exceed 3% by weight for both PET and HDPE for mortar formulations, and also waste PET and HDPE can be said to be used, but at most 3% replacement mortar. And this will not compromise the strength of the resulting mortar for construction purposes.
All right, a very good afternoon to our organizers and our participants. I want to continue the presentation, starting with the concrete results. What Delali talked about was just the mortar results. I want to explain how the plastic waste fared when they were added to concrete. Now, when you look at this slide, you can see two graphs. The one on the left is a slide or a graph presenting the Sloane test. Now, when you talk about the Sloane test, we are looking at how much water the concrete needs to form a workable paste. You understand that too much water weakens concrete, and too little concrete, water will make it stiff and thereby leading to segregation. So you want to be sure about the right amount of water to be used, especially if you are adding a foreign material such as the waste plastic. And so, as you can see from the Sloane test, it is observed that Sloane increased as the waste plastic content in the concrete increased from 0 to 5. You could tell that when nothing was added to the concrete, the Sloane was around 55, but when it was replaced with 1, 2, 3, 4, 5% of the waste plastic, the Sloane increased. This is an indication that when you add water, when you add plastic waste to the concrete, you need to check the amount of water, because you may have to reduce the water as you increase the waste plastic content. And when you look at the graph on the right, it is talking about water absorption. Now, water absorption is a very critical parameter when it comes to concrete works or mortar works, because as much as possible, you want to prevent too much water seeping into the concrete. When you have water seeping into concrete or other chemicals seeping into the concrete, it can lead to chemical reactions inside the concrete, thereby leading to lower strength and eventually poor durability. And so as much as possible, you make sure that the concrete is without pores. And so it is very crucial for you to check if you add the plastic waste, pores are created as a result of the plastic waste. So when you look at the graph, it is observed that as you increase the plastic waste content, water absorption also increased. And these are the indication of high porosity and thereby high permeability. But it must be stated that even though the water absorption increased, it was still below the minimum or the maximum water absorption required, that is 1%. All the replacement levels had their water absorption less than 1%, which is a very good indication. So as we move on, we want to talk about the results for the compressive strength. Now, compressive strength, when it comes to engineering or construction, is a primary parameter required, because engineers look at strength and they are not always interested in what causes strength, but the strength as they have it on the field. And so, as much as possible, you want to look at the effects of the addition of the waste on the compressive strength. And compressive strength is just the ability of the material to resist load. As you put load on it, you want to see how it's able to resist that load. So when you look at a 7 days compressive strength test, it is observed that PET and HDP all reduce in strength as you add the plastic waste from 1% through to 5%. Compressive strength reduces as you add it along. But then it must be stated that the 7-day compressive strength was, however, within the required standard. Now we are looking at C20 as the grade of concrete, and the minimum strength requirement for 7 days when you are considering C20 grade concrete is 13.5. It is observed that up to 3%, we obtain a compressive strength of 13.5 megapascal, which is a very, very good indication. Then when you move to the 28-day strength, it is also seen that by 3%, we were achieving C20, we were achieving 20 megapascal. It means that the optimum strength replacement is around 3%. If you go beyond 3%, you realize that the strength is coming down, which is not very good for construction. All right. And one of the parameters, mechanical parameters that are also important when it comes to construction is the flexural strength. Now, the flexural strength is just the ability of the material strength. It is also important that you look at its ability to resist bend, especially if you are adding foreign materials. Now you realize that there were marginal changes when it came to the flexural strength. And when you consider 2%, 3%, 4%, they were just around the same figure, 4.5, 4.5, 4.7, 4.8. The differences were not so much. But I must say that flexural strength is about 10 to 20% of the compressive strength. So even if you are looking at the highest side, that is 20%, you realize that 20% of our compressive strength, which was 20, is around 4. So it means that the minimum strength we are looking for the flexural strength should be 4 megapascal. But if you look through, we realize that all the strength we are getting are beyond 4, 4.5, 4.7, 4.8, and all that. So it means that it is very, very good in terms of flexural strength, even though we have added the waste plastic. It is still good when it comes to flexural strength. Now, this may significantly be because of the nature of the plastic, its angular nature, and the way is able to fit in very well when it comes to the mortar bars, the concrete bars. So it makes it very, very easy to fit in very well, enforcing the strength and making it strong enough to resist the load. All right. So after the flexural strength, we also try the waste plastic on ordinary blocks, because for an ordinary person, you may not need to go into the lab to do any test and all that. They have to just do it on the field. And when you go to the field, people do not use laboratory standards. So as much as possible, we try to replicate what happens on the field with the plastic waste. But now that you have already assessed it and you know that our optimum is around 3%, we decided to just work on 2 and 3% and not go beyond the 3%. And if you can see from the graph, you realize that the control, that is the material without the plastic waste, is obtaining strength around 5.5. Now the standard for blocks says that you should not get anything below 2.8 megapascal. And so for this one, the control is having a 5.5 megapascal, which is very, very good, way going beyond the minimum standard. But if you add the 2%, you realize that the strength increases. For PET, it increased to 7, and for HDP, it increased to 7.5. And when you add 3% of the same plastic waste, for HDP, we are seeing 7.22, and for PET, we are seeing 6.17, which is very good. They are all going beyond the control. Now, per the analysis, it could be said that is because of the fine nature of the plastic we used for the plastic block. The plastic waste that was used was less than 1 mm, which is sometimes even finer than the sand that are used. And so we believe that because of its nature and its fineness, they are able to see the pores, thereby making it more consolidated and more dense and increasing the strength. So these are just some of the field observations. We also try to build some demonstration walls on the outside environment, all for durability. We want to see how it fares after it rains on it, after it shines on it, after it has been exposed to the environment for a long time. How does it fare in the environment? So these are some of the pictures that are seen. On the top left, you have the HDPE mixed with one brand of cement called Pozo mix, and that's when it was freshly built. And on the right hand side is the current state of the wall. It still looks very, very much okay. It has not deteriorated, still standing, even though it has been exposed to the environment for more than a year now. It looks very, very okay. And the down left is PET that was prepared with ordinary Portland cement, and that was the state when it was freshly built. And that the picture on the right hand side is the state as it is now, still strong and still very, very much okay. All right. Okay, so on this slide you can see pictures of plastic bottles, waste plastic bottles that have been used to construct. On the left hand side is a partitioning wall. It has been used to construct a partitioning wall that is found in our offices in BRRI. It was built from the floor level to the ceiling level, and it has been plastered. Just that we decided to leave a small space so everybody can see what was used to build this particular wall. It looks very, very beautiful, and as of now, it is still standing and not seen any defects yet. And on the right hand side, we are building a security post using the plastic bottles as well. And if you can see, we used ordinary blocks for the substructure, and the superstructure we have started using the waste plastic bottles, and this is the state it finds itself now. We hope to continue so that it gets to the roofing level.
So, as you can see, results obtained so far suggest that waste plastic in construction leads to the following benefits. It leads to recovering of valuable resources. It leads to and these results can be used to raise awareness across society, and this will greatly contribute to a clean and sustainable Ghana. So in short, all that we are doing is in this picture. We are using waste plastic to combine with aggregates to form coated aggregates and use for road construction. We are using waste plastic to combine with bitumen and use it for road construction. Waste plastic is being combined with sand for pavement blocks. Waste plastic is being combined with cement for mortar formulation and concrete blocks, and this will be used for construction of toilet facility. From that, using waste plastic for all this would result in enhanced road performances as it improves the lifespan of materials in extreme weather and traffic conditions, as found in the 9 and 13. Now, with the waste plastic modified mortar and concrete, it can be used to produce lightweight concrete. It is it minimizes the quantity of plastic in landfills and water bodies, and also conserves energy. What is the way forward? A 5-seater toilet facility will be constructed using the modified, which currently has only 4-seater toilet facility and is serving about 450 school children and teachers. We are also with modify mortar, blocks, and concrete. There are also collaborations underway with some other communities to construct roads using waste modified aggregates. Stabilization of lateritic soil with waste to tie rubber for low volume road. We are also continuing with using whole plastic bottles with various soils at various moisture levels as walling material. As we do all funding to be able to all that is on waste plastic. We are also seeking to collaborate with relevant institutions and researchers in experimental and field pilot studies for grants and for exchange programs. We want to thank you all for your attention.
Thank you so much, Trinity, Kelly, and Delali. So now we're going to move on to our question or discussion session. May I ask that if you do have a question, if you look at the left-hand side of your screen, there should be an attendee list, and there will be a smiley face emoticon. If you want to ask a question, please click that and raise your hand. And so we do have a question from our office, actually. My colleague, Nazi Mbongwa, would like to ask Kelly something.
Okay.
Hello. Hi. Hello. How are you guys?
Fine.
Very well, thank you.
Good. Thank you so much for the presentation. So I'm really interested in what you guys are doing, but I just wonder, does this only work for code or polymer number 1 and 2? Because I'm more interested in knowing what happens to all the other plastics that are unrecyclable. So does this only work for polymer code 1 and 2? And what happens to the others?
All right, this is what we have started with. And for now, the work was not started too long ago. And so we just have to start from somewhere. And so we started with HDP and PET. And subsequently, we can take a look at all the other types of plastic and see the way forward.
Oh, okay. All right. Thank you so much. I hope you can find solutions for all the other plastics that are non-recyclable.
Yes, we do our best. Apart from in construction, I'm sure waste plastic could be recycled for other uses as well. So even apart from plastic, we will look at the other possibilities. Yes. Thank you very much.
Thank you.
Are there any other questions from our attendees? I can't see. Oh, here, Holly.
Any more questions?
Holly, perhaps if you could type your question in the main chat.
Okay.
So, Trinity, I don't know if you can see the question there in the bottom left-hand side of the screen. Holly asks, have you heard of Waste Aid? They work with LDPE and cement.
Okay, we haven't heard of them, but we'll find out about them.
So Jeannie has a question as well. She wants to know, I'm new in the recycling space and looking forward to learn more. This was very informative. Thank you. So rather a comment than a question.
Yes.
Thank you, Jeannie.
Thank you too, Jimmy.
We're just waiting for a response from Holly. Sorry, Holly, for some reason I can't put you on audio. Holly says, thank you so much for the great chats. Alex Kumaladi Jr. is working on the topic. Maybe good to chat with him. I don't know if you can see that.
Yes, yes, yes.
Great. Are there any further questions from any of the attendees?
Holly, is there any way we can get Kumiladi's contact?
So while Holly's giving you the contact, Steve asks, just wondering if the concrete can reach 30 MPa?
Yes, it's quite possible. We may have to look at the addition of chemical admixtures or activators to see how it fares. For now, we are getting around 20 megapascal, but in the future, I mean, you try to improve upon the strength and looking at the possibility of adding chemical admixtures to see how it also fares. Yeah.
Great. Any further questions? I think they're pouring in slowly over the chat. So Jenny Rump asks, what are the bottles filled with for building the walls?
Yes, sand, ordinary sand, ordinary sand.
A question from my
yes,
end.
Ordinary sand.
Sorry? Ordinary sand.
Yes, we fill the bottles with ordinary sand with some amount of moisture, not very dry sand.
Have you heard of eco bricks, Kelly?
Eco bricks?
So eco bricks are also soda bottles that are filled with non-recyclable plastic.
Yes, you see something like that on the internet. I'm sure some people are also into that kind of thing. Yes.
Yes,
But
so we actually
don't
have
mind
a couple of those.
Okay, we don't mind looking at that one too here. If you don't mind, we could also look at the possibility of collaborating so we can also share ideas on it.
There you go, Jenny. I hope that answers your question. So Anna Kukola asks, what happens to the bottles over time, as when they're exposed to the environment, would they not degrade slowly, thus affecting their strength? And she also thanks you for the presentation.
You know, it takes a very long time for the bottles to degrade. Probably it wouldn't degrade now, but over 100 years for some of them. So it will not degrade now. And I believe that when some of them can be recycled and recycled. For the road reducing the cost of making, yes, for the plastic reducing the cost of road, sometimes it doesn't reduce, but when you look at it in the long term, the fact that it's going to take double the durability period, then you realize that in the long run it is more cost effective.
Okay, then Tyler says sharing knowledge, idea, and skills are best practices. So that's kind of the point of the webinar series. So I hope that has happened. Richard says it will be interesting to find out comparative time commitments used in producing the various products. And then Holly says, thanks so much for the great work.
I didn't get that. Is it there? Ah, okay. Okay.
And then we have one question from Nazi again.
Okay, last question. Just for interest sake, I just wonder, how is the municipality reacting to these ideas? Are they keen to be part of this? Are they liking the ideas? Any support from them? I just want to know how the support is like in Ghana this side.
Because it's a new kind of research, it is now picking up. So it is through these presentations that we are going to prove to government and all stakeholders that plastic waste can be used as a resource.
Oh, okay. Yeah. Well.
Then Holly Nell, number one. Does the age of plastics have an effect on the durability of plastics, or can you use aged plastics as well, i.e. plastics collected from cleanups?
Well, for now, we haven't been able to work on the age. They just collected whatever there is over there, and then that is what we recycled. So maybe further studies will have to look at that. But I must say that it is very difficult now to really find out how old or what the age of the plastic at the landfill is for now. In Ghana now.
Okay. So Tyler asks how plastics or all solid waste is the way forward. Also in Ghana, there are many NGOs and individuals that are working on trash. Government should be involved. Seriously, Africa has a long coast and professionals, but still the problem persists. I agree with you, Tyler. What do you think, Trinity?
It is very true. It is true. But gradually, the government is recognizing some of the findings we are getting. So we believe that as time goes on, they will come on board.
Trinity, I guess leading on from this question, have you spoken to the Ghanaian government?
The what?
Have you spoken to your government? Or have you had any communication with your government there about your amazing work?
Yes, we started some communications, but at the time we didn't have a lot of results to prove. So they asked us, especially with the coated aggregate, we met with the ministry, but they asked us to go and do more work, and then we'll come back and present to them. But we have a challenge because we really don't have money to continue with that particular research.
Certainly from our side, we are experiencing similar challenges. I can see Tyler typing. So. Are there any further questions from the attendees? Is there anything you would like to add with your team, Trinity?
Is there anything, my team? For now, we thank you very much for the opportunity.
Thank you so much. Thank you for your wonderful presentation. Thank you to Delali and Kelly as well. And thank you so much for being a part of the Academy and sharing your amazing work. And I hope that some of the attendees from today get in touch with you. And thank you so much for everyone who did attend.